Hey, what's up, guys? So let's talk about our third example, which is non-affine skin. Hope you guys subscribe to my channel if you haven't seen my two previous examples. So this example is also famous. So the reason is that we will show that the open subset of affine skin is not affine. The reason if you like make a video is like probably the only way to make myself feeling alive. Okay. So yeah. So our example is that we will take A to be So before we start, recall that maybe if you learn about differential geometry, right, or whatever, you know that if you take maybe R square, right, and you take an open subset of R square, for example, you minus the 0 point, then you can show that this is isomorphic to sphere, right? So this is flat, right? But if you it's flat space, right? If you minus a point, then become will not be flat, right? So that means that if you take the open subset of some space, then that space may be simple, but the sub-open subset of that space may be very different. So this gives us the hint that if somebody take the affine plane, let's consider K to be algebraic closed. Okay, and then you take the U to be the open subset, so AK squared minus 0. Okay, so this is open. Why? Because you can write as a distinguished open set d of x. So d of x basically just tell you that x is non-zero, or pi cannot contain x, the same as x is non-zero. Union y d of y, right? So y is non-zero. So this is the same as you take the union of two open, right? By definition. So if you minus 0, either one of coordinate should be non-zero, right? So this proves that U is open. Okay, so U is open, and so by the previous, there's a in the future that so basically one can prove that the open subset of a skin will be skin. This is non-trivial. But basically, I want to show so U is a skin. The structure shift on U is basically the same as U restricted OX, the original affine plane structure shift to U. Okay, so claim is that U is not affine. Okay, so as we prove something, right? We need to I want to show that U is not affine. I need to calculate a global section, right? So once I compute the global section, for example, the global section is A, then I can just claim that U should be the spec of A. And I want to see where there is a contradiction between them. If there is a contradiction, then I prove that this U is not affine. So what is the global section of this U and OSU? So what is the global section? Okay, so this is simple because we can ask, right? We can ask what's the function on d of x, right? Because in this example, it's simple that I already know U is dx union dy, right? So I can ask what's dx. Right? I ask what's the function of dx. But this is simple, right? Because I know that the dx is just global function is just x is non-zero, right? So I can invert x, right? So it should be the coordinate ring, or should be the k of x, y, and 1 over x, right? Because x can be non-zero, right? And obvious, this is just definition, right? Almost definition. And if I take d of y, then I should get the k of x, y, 1 over y. And right, so obviously that we have the following diagram. So kxy can be mapped into k of x, y, 1 over x, and the k of x, 1 over y, or can be also, this is injective map, right? But your space is the union of these two, right? So your global function should survive on these two, right? Both, right? So your function should survive, right? So your OX, right, should be the function that survive on both, right? So so you need to find an element which they are equal, right? But this guy contains 1 over x, right? This guy contains 1 over y. So the only possibility is that there should not be 1 over x and 1 over y. So your global function will be kxy. Because you want to find a function. So let me say again, you want to find a function which survive on both. So it looks like the form of this. But if there's a function which looks in this and in this, they should be the same. The only possibility is that there should not be 1 over x and 1 over y exist. Right? Otherwise, if there is a something plus 1 over x, then there's no way that this something plus 1 over x can be the same as something plus 1 over y. Okay, so let's tell you that this is our results. Then this tell me that the spectrum of this x this opens at U, right? Should be, yes sir, it's U. So it should be isomorphic to the spec of k of xy. So basically a fine plane. Okay, so this is the same as. So now the problem is that how can one show U is as a space or as a skin should not isomorphic to a fine plane? How can we prove this? In the VCAL, the argument is very simple. So argument just saying that in AK square, right? If you take a Vx and a Vy, so vanishing set, basically this just tell x is 0 and y equals 0, right? Should cut out a point. Cut out a point. This is the same as v of x intersection with y. So you need to find a function which vanish in prime ideal, which containing x, right? And prime ideal containing x, and the prime ideal which contain y. Okay, if you view as then this is the same as vxy. Okay, so this will in the cutout point will be 0, 0, right? Because very simple, right? You're basically just asking that the vanishing set of x and the vanishing set of y, their intersection should cut out point called 0, 0. Okay, but in U, right? If you ask what is v of x and v of y, will cut out to be empty. Will cut out to be empty, right? Because there's no 0, 0 that you can cut. So if you ask this, if you ask x equals 0 and y equals 0, that you get empty. Okay, so this show that U is not fine. Okay, and yes, this example is important because in the future that we will always using this kind of example. So the three kind of the summary of these three example, a finite line with double origin or a projective line, and this example are very important. That you can start from here, and in the future that you can always keep using these three examples, non-affine examples. See you guys next video.